Hello, welcome to this training video. My name is Noval. I'm gonna show you how we're gonna simulate metal sand casting practice using two softwares, that is SOLIDWORKS and also Novacast. For those who don't know about these two softwares, SolidWorks is 3D modeling softwares that oftenly used to create 3D objects that you want to create or you want to draw. So basically, uh, engineers can call these softwares as CAD softwares, or it pronounced as computerized aided design. And the second software that I'm going to use is Novacast. Novacast is a software where we can simulate metal sand casting or other casting of molten metals with softwares. And then we can categorize these softwares as CAE softwares, or we can call it as computerized aided engineering software. So these two softwares are the one that we're gonna use for simulate metal sand casting practice. So let's start with, let me share my screen. So for the start, I'm already create an example of objects that I want to simulate later. So I will explain a little bit about sand casting basics. So when you want to do a sand casting practice, you need to create a mold where the mold contains three parts. The first part is ingate, where there will be a hole where you want to pour molten metals there, and the main material where you want to put your design, and then there will be riser. Riser function is uh, as a empty space so that there will be more molten metals that can be poured into the mold, because there will be a shrinkage when molten metals freezing. So you need riser in your material design for simulation. So I have ingate, I have my uh, main materials, and also I have a riser. So let's start designing our products. Choose new, choose part, and click OK. For this design, I'm gonna use centimeter as the measurement and choose top plane for my canvas draw. So let's choose polygon. For this design, I'm gonna have 6 lines for my polygons. Click OK. For the dimension of the circle, diameter would be 15 centimeters. Click OK. Exit your sketch, choose feature, and extrude boss. So for the thickness of this area, I'm gonna input 5 centimeters. Okay. And I will draw another part for my main design with normal to. Let's create something different, not N, but let's just circle. For the diameter, let's choose 10 centimeters. Okay. Exit the sketch, click feature and extrude boss. For this area thickness, let's input 3 centimeters. Click OK. And let's create our in-gate and our rise. Don't forget to normal to, and let's create 2 circles. One should be bigger than the other. Okay, click OK. For this, I didn't have to input the diameter measure. We didn't have to be specific with features and extrude boss. For the height will be 5 centimeters. Click OK. Now we have our main materials, the in-gate, and also the risers. So in real life, people oftenly cut or throw away these two parts because uh, the main material, the main product that they want to get is this area and not the riser or the in-gate. So we can consider that casting products is half products, and also we can consider it uh, not the end product. So we save the file as STL because this file oftenly used for 3D printing and also simulation. You can choose any place you want. Click yes and okay. Now let's open our Novacast softwares. First thing you need to do is import your file and then turn the file into .cvg. Okay, you can see that the position of the product that you already designed is not in the right axis. So you want to pour the metals from the top, and this angle is just not right. So let's input 90, and then hope. I guess we uh, put the wrong number. There you go. Now you can rotate like the way you want, and then you click fix orientation. Now the orientation of your product is already fixed, and then you can click file, save the assembly as CPG. You can choose any uh, document where you want to save your product. For now, I'm gonna uh, choose my own document to be saved here, and then click save. Now that your file is already saved in CVG format, you can exit and then uh, click the simulation set. So now, what you need to do the simulation is you need to create mesh so that the computer can can do the simulation of the metal being poured into the empty space inside the mold. So create mesh. Now about the parameter of the mesh, I want to explain you uh, the more complex of your design, the dimension of cell that will be needed is gonna be way more bigger, and the calculation time will be way more long. So I will lower uh, the cell. So you notice that the dimension is increasing, and the cell along x-axis, y-axis, and z-axis is decreasing. So the lower your cells, the memory of simulation will be way more lower. So the calculation time will be more shorter. But this will result an inaccurate calculation, but it's okay for us because we want to show the simulation video of the softwares. So click OK. Now, this is the imaginary of the mod that you're gonna use. Let's set the material for the part of your material. We're gonna use ductile cast irons. You can choose other material. Let's take malleable cast irons. The material type, the initiate of temperature, you can edit it as well, but to us, it's already correct. The mold material, you can use other materials, but uh, for this simulation, green sand is okay because we want to do sand casting simulation. So click OK. For gatings, now you press Shift button and then put your gatings, the place where the metal will be get into the empty space of the mold. Click Shift. Oh, okay. There you go. So the metal will be come into this area and then going down to the bottom. Click OK. You select feeding point. So the pouring point of molten metals would be not far from the gatings. Click OK. So this menu right here, uh, this is a type of menu of coating, select particles, flow colors. You can input into your simulation. Flow colors is, I think, for the distribution of temperature. So when the molten metals is freezing, there will be the change of color from red into the gray color, just like the iron when they're melting, uh, and then the solidification happen. So there will be heat distribution simulation, but we don't do that now. We just want to show the simulation of molten metal flows. Choose the filling parameters. For the filling stop criteria, we want the filling to stop at 100%. So we want to choose this option. The gatings is only one we choose, and the type of pouring is graffiti casting because we want to simulate the simulation using ladle. The time of the pouring is important. Let's choose 10 seconds because in metal casting simulation, you cannot be slow when you're pouring your molten metals. For the flow kilogram per second, I want to put 2 kilogram per second. Let's click OK. There will be another option like temperature distribution, shrinkage, uh, sulfur setting, preheating simulation, but we're not using that option now. Let's change the color of our model into gray, just like the real metal. Click File, Save As, choose your saving destination. Now it's already saved. So close your softwares and then you choose Flow and Solid. You can see that this is the ingot, and this is where will be the molten metals get into the empty space of the mold. So this is empty space, and the area outside of your object is a sand. So let's start the simulation. Click Simulate, Start Simulate. You can see that it's not detailed the about the molten metals that get into the system. It looks like the dripping is not perfect because we choose the lowest mesh that we used before. So the calculation or the distribution of molten metals is not perfect. But if you want to create um, a more specific calculation or simulation where the molten metals being poured um, way detailed. So you only have to increase your mesh parameters. So this is how we simulate metal sand casting with these two softwares, which is SOLIDWORKS and also Novacast. So I'm gonna stop the simulation, and that is the video of tutorial that I want to show you about these two softwares. So thank you and goodbye.